when we looked at electric fields, we saw that electric field moves from what to what? Moves from the positive to the negative. Okay? Well, we have the same thing with magnetic fields. Only instead of moving from a positive to a negative, we have it moving from the north to the south. Okay? All magnets will create a magnetic field. Magnetic fields are vector fields, which means what? Magnitude and direction, okay? And the direction is defined by north and south compass points. East, west, however it works. Okay, so what you can see here is the south end here and the north end here. And we see that it flows out of the north, and into the south. Okay? Now, here's the thing that boggles everybody's minds and they get tripped up massively. Our North Pole, which is several hundred kilometers north of us, 1,000 kilometers north of us, this is up here, and we call it our geographic north. And south of Chile, when we're going towards the Antarctica, we call that the geographic south. Because our magnetic field, we can see that it comes in on our north end and it comes out on our south end, which means that the internal magnet, that is our core, must be south at the top and north at the bottom. So the internal magnet that is made up of the Earth's core, which is where we find the molten lava, the melted rock having the big component being iron. Okay. Our geographic north, which is the Arctic Circle, is our magnetic south. And our geographic south, which is the Antarctica, is our magnetic north. We have an internal magnet inside of the Earth. Okay? Can we what, Avery? Okay? So this internal magnet that we have in our Earth's core, the magnetic south is our geographic north. Because we know the magnetic field does this. When we hold a compass and we say that this is north, it's actually pointing to what attracts, right? North and south. They attract, like positive and negative. North and north would repel. South and south would repel. So our north, that little hand in the compass, is magnetic, and it points to the north because that's the south end of our Earth's magnet inside the core, inside the Earth. And so we say, well, that's the north. That's geographic north, but it's magnetic south. Okay? So if you have a compass sitting in your hand and north is pointing that way, that must mean the south end of a magnet is over there. Or if you were out in the bush and the north was over there, that's magnetic south. Geographically, it's north. Magnetically, it's south, because you have to have an attraction. Okay? So magnet lines always point out of the north and into the south. Out of the north and into the south. Okay? Now, when we had two charged particles that were the same, we saw that it flows out in a positive, and we would have repulsion, right? What is the electric field strength in this zone in between? 0. The same thing happens in here. There is no magnetic field strength in here. This is another dead zone. These are two magnets that repel. Same idea with south. This in here is also a dead zone. Yeah, this one in here, there's no magnetic field in there. Okay? Same idea as our charges. Just like we have a neutral body of charges, and we bring in a rod, let's say this one is negatively charged. What happens to the ions in this ball? How will they align themselves? The electrons will move away, so you'll end up with a ball with the same number of charges, but a different alignment based on this rod having a negative charge. The same thing happens in a body that has north and south magnets in them, essentially. If I bring in a bar magnet and I know that that's north, what's going to happen? All of the norths will move this way, and all of the souths will move this way. And just like induction, we can force that charge to happen. Okay? So it's the same principles, only instead of being charges, now it's magnetized particles. All right, let's compare. Gravitational fields we looked at in Physics 20. And electric fields and magnetic fields we're just looking at now. So in gravitational field, right, G m1 m2 over r squared, what is our source? You have mass, charge, or magnets. Mass. Mass is our source for gravitational. It depends on your mass what your force gravity is. Okay? The direction is towards the center of the mass. Right? Gravity on Earth works directly towards the center of Earth. So it's only related, it's only towards the center of that mass. Electric fields being KQ1, Q2 over R squared, what is its source? Charge. Okay? Now, it can act away if it's positive, or towards if it's negative. right? An electric field moves away from the positive and into the negative. Okay? Magnetic fields, their sources are magnets. And a magnetic field will move away when it's positive, and it moves towards when it's negative. And it's the magnetic poles. Okay? So let's go through these questions 1 through 6 on page 136.